I mean, that's what you would do for lead. That's what you would do for iron toxicity, nickel toxicity, any of those. So you would actually undergo chelation. Athermormic syndrome. I love that name. That is just like one of the coolest names. Crazy disorder. Limbic channel. Ooh, limbic channel. Remember that? No? We talked about it the other day.
Yeah.
Through the striatum and globus pallidus is damaged. Loss of motivation and executive function, leading to complete apathy. We have all had that day where we said, I don't want to get up. Okay, fine. No, I'm not going to go to school today. No, I'm going to call in sick at work today. No, I don't want to get up and make breakfast. You make breakfast for me? Yeah. The apathy with athermormic syndrome tends to be much more severe. This is where the person, sits down. Oh, you want to have some breakfast? Okay. Okay. You go to the bathroom? No. You move your arm. Like. Okay. Complete apathy. I mean, it's like a complete loss. And as it progresses, it becomes. So you're sitting there. You move your arm. There's no motivation. You move it. You put it here. Okay. Where it is. And they'll stay there until the muscles fatigue. So it can be a complete lack of, and the initiative, there's an initiative function in here. We talked about initiative somewhere earlier, and I don't think I ever got into that. But you actually have brain pathways that allow you to initiate things. And if you don't do it, you're stuck. But once again, problem with the striatum, problem with globus pallidus. Sydenham's chorea, or chorea, also called St. Vitus dance. There are I think there's some videos, YouTube or on the internet. There's a St. Vitus festival, I believe, in Switzerland, yeah. Once again, people get weird movements. So in the St. Vitus parade, you see these people all, they all hop along together down the street. They get dressed up in fancy costumes and hop down the street. It's a couple of things have been associated with this. Number one, it appears to be an autoimmune disorder that leads to damage in the striatum. And there might be an association with certain types of mushrooms. And I don't mean fun mushrooms. I mean like, mushrooms you would eat for dinner. So, pretty bizarre. So you eat mushrooms, so you get an autoimmune disorder, and you become really weird. So, yeah. But these, I think most of these are mentioned in your textbook, by the way, somewhere in this chapter. So, yeah. I do want to go back to neurotransmitters. I'm of the opinion that in general, students don't understand neurotransmitters. And if you don't understand neurotransmitters, you're not going to understand why drugs are used to deal with them and what the complexities are. What I would like you to know about the neurotransmitters, okay, as we go through this, I want you to know if they're excitatory, inhibitory, or both. I would like you to know if they have direct action or indirect action. I'm going to show you in just a second what I mean by indirect action. Direct action means that the neurotransmitter binds to a channel receptor. By binding to the channel receptor, it opens an ion channel, and it's going to lead to an ionic event. That'll either be excitatory or inhibitory. So, with direct action, the neurotransmitter, so we have channel. Neurotransmitter binds to the channel opens, and ions move one way or the other. So, and this will either, if it's excitatory, in the target, it will lead to a new action potential. If it's inhibitory in the target, it will lead to hyperpolarization. Indirect, and I'm bringing in a slide that's a little bit complicated, but we're gonna simplify it. Indirect, there is no channel. The neurotransmitter binds, and here we have a G-coupled protein. That's going to go to an enzyme that's in the membrane and cause the production of a second messenger. More often than not, the second messenger is cyclic AMP. So this second messenger can then do many different things. It might code for the production of a new neurotransmitter. It might lead to a depolarization event. Those are the two things you should be concerned with at this point in time. Near the end of next week, when we talk about some of the hormone stuff, second messengers can actually lead to hormone production. So do you see the difference between direct and indirect activity? Because when we look at these, it's going to tell you. Okay, so in the central nervous system, we have the nicotinic acetylcholine receptors. We have either these interact via excitation with direct action. So the acetylcholine will bind to an acetylcholine receptor. A channel will open. Since it's excitatory, we're going to have the movement of ions that's going to lead to a depolarization event and a new action potential. Okay? The muscarinic, which are in the peripheral nervous system, have indirect action. So the acetylcholine is going to bind to a receptor, and then you're going to have a G-coupled protein that leads to the production of a second messenger. And you will then have either an excitatory or an inhibitory response. Yeah?
You said the receptor is linked to the G-coupled protein?
The G-coupled protein, if the neurotransmitter doesn't bind, the G-coupled protein is bound to the receptor. When the neurotransmitter binds, we have a shape change. So this is going to undergo a shape change. It's going to release the G-coupled protein, and as long as the neurotransmitter, the ligand, is bound, this can't rebind. This is going to move on. It's going to interact with some enzymatic protein that's going to lead to the production of messengers. It is a really cool system, and many of your cells that respond to hormones respond via second messengers. So it's important, yeah.
So just to make it clear, for indirect, there is a second messenger, but with direct, there is not.
That is correct. The neurotransmitter with direct stimulation is indeed the messenger.
Okay.
With indirect stimulation, the neurotransmitter is the first messenger, and some other chemical, usually cyclic AMP, is the second messenger. So, the first messenger is always on the outside of the cell. A second messenger is always on the inside of the cell. Yeah?
So for acetylcholine,
Yep.
the direct pathway is always excitatory.
No.
No.
Oh, right. Yes.
Okay.
It is. Sorry.
And then the indirect could be excitatory.
Either or. That is correct. Yep. Once again, these are posted now. So. All right. So norepinephrine. Excitatory or inhibitory, depending on receptor, and it's indirect. So, what you can do is sit down, make yourself a little table. All right? Dopamine, excitatory or inhibitory, indirect. Wow, we're seeing a theme here. The indirect pathways are much more dominant. They predominate. They're the predominating type of receptor. And the beauty of that is that essentially, as far as the inside of a cell goes, you only need this simple mechanism, the G-coupled protein mechanism. This binds, G-coupled protein mechanism works, something else happens. With this, every one of these does something different. So this is kind of a catch-all. This piece that binds to the neurotransmitter is different for every receptor type. But still, within the cell, everything kind of works the same after that. That's kind of neat. Serotonin, overwhelmingly inhibitory. Oh, darn, look at this. Mostly indirect versus a second messenger. You can have some that are direct. So as far as serotonin goes, indirect and direct. So it's both. Histamine, excitatory or inhibitory, direct action. So it would be pretty simple to make a sit down, like I said, make yourself a little table. GABA. GABA and glutamate are what I want you to pay attention to here. GABA, inhibitory. It's overwhelmingly inhibitory. All right? Has both, direct and indirect. Glutamate, overwhelmingly excitatory. Direct action. So. Endorphins. Endorphins, substance P, endorphin, dynorphin, and enkephalin. We're going to be coming back to those in a next week. Inhibitory, indirect. Substance P, that's what we've talked about so far. Excitatory, indirect. We haven't done the other two. Don't worry about the other two. They're more associated with some specific pathways we have. I want you to visit